Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Honors Geometry class. Today we're going to be learning about 4 ways to prove triangles congruent. And in order to do this, you really have to understand how to recognize corresponding sides and angles. So let's get right to it. The first postulate we're going to learn today is called the Sss Postulate. And that stands for side, side, side. And the Sss Postulate states, if 3 sides of one triangle are congruent to the corresponding sides of another triangle, then the 2 triangles are congruent. So let's consider the 2 triangles that we have here that are joined together by segment BD. We have triangle ADB and triangle CDB. If we look at the corresponding sides here, my friends, AD corresponds with CD, and which you can see they're both congruent. DB corresponds with DB because of reflexive property, it is congruent to itself. And last but not least, AB and CB, okay, they correspond to each other and they are also congruent according to the figure. So we have 3 sides of one triangle, being ADB, are congruent to the corresponding sides of another triangle, being in this case CDB, so that makes both triangles congruent. Side, side, side. The SSS postulate. Next, the SAS. SAS stands for side, angle, side. And the side, angle, side postulate states that if two sides and the included angle of one triangle are congruent to the corresponding parts of another triangle, then the 2 triangles are congruent. That is SAS, side, angle, side. Let's take a look at the congruencies here, and let's see if we can understand this a little bit better. Side AB corresponds with side DE, and according to our figures, those are congruent. Side BC corresponds to side EF, and according to our triangle figures here, those are congruent. And angle B corresponds to angle E, and according to our figures, angle B and angle E are congruent as well. So we have a side, angle, side. We have 2 sides of one triangle and the included angle are congruent to the corresponding parts of another triangle, making both triangles congruent. SAS, side, angle, side. Does that make sense, gentlemen? Okay. May I continue? Awesome. Thank you, gentlemen. 2 more, guys, and then we'll get to actual practice. Now we have the ASA, which stands for angle, side, angle. And the ASA postulate, or the angle, side, angle postulate, states that if 2 angles and the included side of one triangle are congruent to the corresponding parts of another triangle, then the 2 triangles are congruent. Angle, side, angle. Let's check out the correspondences here and the congruencies, and let's see if we could make this more understandable for you guys. So if we look at angle B here, angle B corresponds with angle E. And according to our figure, angle B is congruent to angle E. If we look at the next correspondence here, let's take a look at angle C and angle F. Angle C and angle F, according to our figures, are also congruent. And then we need that side that's included, the included side in between both of those corresponding congruent angles, which in this case is BC, which is corresponding with EF, which BC and EF are also congruent. So if you really look at this carefully, I have angle, side, angle. And that is the ASA postulate. Angle, side, angle. 2 angles and the included side of one triangle are congruent to the corresponding parts of another triangle. Then the two triangles are congruent. And last but not least, this is not in your book, so please pay extra special attention and care to this postulate, because I repeat, it is not in your book. The AAS postulate. The AAS postulate stands for angle, angle, side. If the two consecutive angles and the following side of one triangle are congruent to the corresponding parts of another triangle, then the two triangles are congruent. I want you to think about this kind of like in the way of clockwise or counterclockwise, okay? The angles are either going to be flowing clockwise to the side right after them, or the angles are going to be flowing counterclockwise towards the side that follows them as well. Let me explain it with actual visualization. If we look here at the corresponding sides, let's check out AC. Well, actually, let's go the actual direction. Sorry about that. It's angle, angle side. So let's start with the angles. I apologize. If we look at B, which is corresponding to E, we got BE. Next in that flow, in this case, we're going counterclockwise. We're going to C, which is corresponding to F, which also are congruent. Okay? And then if we continue in that clockwise manner, it takes us to these two sides, which are AC and DF. And AC are not only corresponding, but they are also congruent. So I have angle, angle, side. Okay? I have angle, angle, side. And if we look at this again, I'm going to kind of clear this up for you. We're going in a counterclockwise manner in this case. I'm going angle, angle, side. Angle, angle, side. Yes, sir, you have a question. Okay, the ASA postulate has a side here in the middle, in between, my brother. Yes, sir, hence angle, side, angle. This one has to follow the angle, angle, side. So it's two consecutive angles followed by a side. That's a very good question. Thank you so very much. I really appreciate that. So again, my brothers, if two consecutive angles and the following side of one triangle are congruent to the corresponding parts of another triangle, then the two triangles are congruent. And it will always either flow clockwise or counterclockwise. In our example, it was flowing counterclockwise. Very, very good question, by the way. Thank you so much. Are we good here, guys? All right, and may I continue, gentlemen? Let's do it. All right, thank you once again. All right, guys, let's figure this out. So name the additional congruent sides or angles needed to prove that the triangles are congruent by each specified method. So here, gentlemen, which two sides have to be congruent to prove that these two triangles are congruent by side to side? Yes, sir. Okay, AC must be congruent to HG. Absolutely. AC must be congruent to HG. Awesome. How about for side angle side? I'll change the color so you can see the difference. Yes, sir. Angle B must be congruent to angle F for side angle side. Absolutely. Fantastic. Well done. Well done. I'll leave it up just in case you need to write the answers, but let's move on to example 2. In this particular case, guys, what do we need to be congruent? Yes, sir. Excellent, son. We need segment OM to be congruent to PQ because they're corresponding and must be congruent. So to prove SAS, we need OM to be congruent to PQ. Excellent. How about angle, angle, side? Angle, angle, side, angle M, very good, buddy, has to be congruent to angle Q. Very good. Very good. And for this one, I'm just going to erase the blue just for a second because I don't want you to get confused, because that was the question that my boy had asked earlier. For angle, angle, side, it has to work this way, guys, because it's angle, angle, okay, and then side. So in this case, it's going angle, angle, and then side. Angle, angle, and then side. Does that make sense? Next, my brother. Here, let me just take this away. I don't want to confuse anyone else here. Okay, and let's put back the blue, because that was for side, angle, side. Okay, my man. For angle, side, angle, what would I need here, sir, please? Angle N. Beautiful, son. Beautiful. Would be congruent to angle R. Phenomenal. Because angle, side, angle. Excellent, sir. Angle N must be congruent to angle R. Well done. Well done. Making sense? All right. I'm going to continue now. Next. Now let's be careful here. Check this out. We got a little bit of a complicated one here. We're talking about, I want to prove specific thing here. I want to prove that PWT is congruent to SVR via side, angle, side. How can I do that, my brother?
Segment TW must be congruent to the segment WR.
Oh, very good, son. TW must be congruent to segment WR? Wait. That's PWT. And then we have SVR. Okay, but let's be careful how we pronounce that. It's not segment. Oh, yes, okay. I see. TW to VR. Yes, you're VR, right? Because W belongs to the PWT. VR belongs to SVR. That's why I got a little bit confused. And actually, to unconfuse us, why don't we do this? I'll put this guy in blue. Okay. SVR here. So VR has to be congruent to WT. So WT must be congruent to VR. Does that make sense? You see how just a couple letters could really mess it up? Yeah, you got a question on that, or?
What if W and V?
Okay, W and V are not the same thing. See how you have a little gap there? Right there in the middle? Thank you, sir. Thank you very much, sir. Okay? I'm going to kind of clean this up right now, though, so that I can make sure that you guys understand what's going on. Oh, okay, sorry about that, guys. Okay, so like I said, I'm going to clean this up for the next one. All right. Now, if I want to prove again, let's focus on what we're proving here, gentlemen. We're proving that triangle PWT is congruent to SVR. Okay? There is a gap between W and V. Okay, so how are we proving with angle, side, angle, sir? Abso-freaking-lutely. Angle P would have to be congruent to angle S because they're corresponding. You're not going by the figures here, if you notice. You're not going by the figures here, as you notice. You're going by the actual letters. So angle P is congruent to angle S. And sorry, he stole that one from you. Go ahead. Next. No, that's okay. No, let him do it. Yes, sir, you got a question. Yes, sir, please, thank you. Yes, sir. Okay, angle, side, angle. Ah, that is a very, very astute question. And actually, I'm embarrassed. It is not angle P. Unfortunately, we're kind of wrong there. It's angle T W. And look what I did. I put WPW. Sorry. Very good catch. Phenomenal, son. Angle TPW must be congruent to angle RSW. And again, it has to be in a specific way because we need correspondences. Hey, we all mess up. RSV. Okay, I was testing you on that one. RSV. Good catch, guys. Thank you so much. You guys are awesome. All right, now, how would I prove angle, side here? How would I prove angle, side here? Yes, sir? Segment PT is congruent to segment SR? That's already given, my man. I'm trying to do angle, side here. Angle, side here. Yes, sir. There it is, my brother. Great job. This angle here has to be congruent to this angle here. Because remember, I have to flow in a clockwise or counterclockwise motion. So it would be angle PWT must be congruent to angle SVR. No, because R corresponds to P, V corresponds to W, and actually, wait, be SVR and PWT. Yeah, because it'd be angle, side, and then angle, side. Sir. Well, remember, what we're trying to prove is that the triangles are congruent, not that those angles were congruent. We're trying to prove why it is. Thank you very, very much, sir. Fantastic question. Okay? Does that make sense, boys? Alrighty. Let's continue. Number 4, using tick marks. Okay? You are using the tick marks for each pair of triangles. Name the method SSS, SAS, ASA, or AAS, if any, that can be used to prove the triangles congruent. So, for A, can we prove that these two triangles are congruent? Why? Well, the tick marks only show me two sides are congruent. How would I use SSS here, though? No, how would I use SSS here? Tell me you're right. What are we missing?
The reflexive property.
Thank you. The reflexive property right here, guys. SSS. How about for B? Can we prove that these two triangles are congruent? Yes, sir. No. There is no side here, tick mark. Now, you may be saying, but Moro, there was no tick mark here. Yeah, but this is a reflexive property. That's kind of a given. But here, I only have two angles, and actually all three angles are congruent. But there's no angle that proves congruency. So this one you can't. So this is NA, not applicable. NA is not applicable. Now, how about C? How about C, guys? What can we do here? Yes, sir. No, this is not angle, side angle. This is angle, side. Remember, my brother, angle, side angle, the side will be in between the angles. Good try. I'm proud of you. Yes, sir. Want the next one? No? Yes, sir. Yes, sir, please. This would be side angle, side. Side, angle, side. Yes. So this one's side angle, side, and this one before was angle, side. Awesome. Awesome. How about this bad boy here? Yes, sir. No, it won't be NA in this case. You're thinking, though. I'm proud of you, but think a little clearer. Yes, sir. Angle, side angle. Fantastic, because reflexive property here, my brother. So we have angle. The side is congruent to itself, right? because it's reflexive. And then we have, whoa, that was kind of cool. And then we have the other angle here. Okay? So this one's angle, side angle. That reflexive property likes to sneak up on you a lot here. Be careful with that. How about F? How would we prove that F, if at all, if the triangles here in F are congruent? Yes, sir. AAS, angle, angle, side. Again, look at the motion here. We've got an angle, angle, side. This is flowing this way, ending at the side. This is flowing this way, ending at the side. Does that make sense, gentlemen? Now, the fun part, the part you guys have been waiting for. Our proofs are coming. Okay, I want you to prove that AEC, triangle AEC, is congruent to DEB. Okay, and this one we don't need a full-on proof, but what would I need to prove this if I wanted to prove it by side, side, side? What would I need? And let's start learning how to identify the triangles, right? So we're talking about AEC, and we're talking about triangle DEB. There is an overlap here. That's why I did this, so be careful. You had your hand up first, my brother. Well, what I need? Absolutely, my brother. AC must be congruent to BD. Overlapping triangles is coming very soon, guys. I'm going to show you how to work with that. But start learning now how to recognize overlapping triangles. What if I wanted to prove the same triangles, gentlemen, congruent, but I wanted to prove with side, angle, side? Yes, sir. Be careful with this one, how you articulate it. You rule. Angle A, EC, this guy right here, must be congruent to angle DEB, which would be this one right here. Absolutely great. Great job there. Does everyone see that one, guys? Because this is where it gets tough. These are the hard ones when you have these overlaps. Does everyone make sense with that before we start proving the real proof in number 6? Okay, I'll take that as a yes. Thank you, guys. Alrighty then. Let's prove this bad boy. All right. They've given us that AD is congruent to CD. So that would be my first statement, and my first reason is, of course, given. Now, B is the midpoint of AC. That could be my next statement and reason. But knowing that B is the midpoint of AC, what does that tell you? Beautiful, son. Segment AB must be congruent to BC, and that's simply definition of midpoint. Okay? Now, think, what else can you prove here, guys? What do you know for sure, 100% fact? Yes, sir. No, you don't know anything about the angles here. You're assuming here that angles are congruent. No one told you that ABD is 90. No one told you that DB is perpendicular to AC. I'm really not trying to be rude or sarcastic, but you cannot assume right angles here, guys. What do you know for sure? Here, let's give him a chance. That's absolutely correct, my brother. Good job, guys. DB has to be congruent to DB, or BD to BD, because of the reflexive property. Does that make sense, brother, why we couldn't go through the angles there, kid? You promise? Okay, thank you. And now, can I prove that triangle ABD is congruent to CBD? Why? SSS, side, side, side. That was a very good proof, and I'm very proud of that mistake. That was a great mistake, actually. Because that's the mistake that we make a lot, and I'd rather make it here in class where we can together correct it instead of on a quiz or on a test. No worries. Any questions on that, gentlemen? We just got one more proof today, guys, but I want to make sure you guys got this for real. Thank you. Number 4 is reflexive property, right? Because we got BD is congruent to BD, or DB is congruent to DB because of reflexive property. Yeah, if you're going to go BD, you got to go BD again. Thank you so much for that question, sir. I appreciate it. Anything else, guys? Remember, that's what I'm here for. This is what I love when you guys are learning. All right. Last but not least, I'm going to go to the next page. Cool? Okay, last but not least. And this is a really nice one. Look at that. That's an 8. An 8er. Okay. This is an 8er. It's pretty cool stuff, man. Okay. Let's do it. Angle 3 is congruent to angle 6. So you know me. I love to label things. So angle 3 is congruent to angle 6. So that's my first statement. That's my first given. My reason is, of course, given. What can you tell me from there? Immediately, think. Think, guys. Go old school here. Yes? Yeah, close. You jumped a few steps there, though, right? You don't have to say that at this point, because we can assume already that KMO is a straight angle, but what we got to say is that angle 3 is supplementary to angle 4, right?
Yes.
And what else? No, not yet. You can't do that yet, guys. This is definition of supplementary angles. Then angle 6 and angle 5 are supplementary. Definition of supplementary angles. Now, what can you tell me about angle 4 and 5, my brothers? Yes, now I can say angle 4 is congruent to angle 5 because supplements of congruent angles are congruent. By the way, I'm proud of you that you guys knew immediately, oh, 4 has to be congruent to 5. I'm really proud of you. However, like we said, we got to explain this step by step. You got to explain why that angle 4 was congruent to that angle 5. But I'm very, very proud of you. Okay? And what I like to do in these, especially when we're talking about these congruencies, I like to already highlight what it is we're trying to prove. Remember that we're trying to prove that triangle KRM is congruent to triangle, I'm sorry, look at that. I don't know how to read. I don't know how to read. Oh, no, I do. I do know how to read. Okay, I was wrong. To PRO. Okay, so we're trying to prove these two guys. So we already have an angle in there. So that's awesome. Now, they tell you, though, that KR is congruent to PR. So this guy is congruent to this guy. So that's going to be my next statement. And my reason is given. Okay. And you know what I'm going to try to do here? Let me see if I could do this. Let me see. I'll try again. Hold on. Let me try on the actual computer because I want to try to move it down so you guys can see the actual flow while we're doing this. All right. Let me see if I could do this. Let's copy. And then let's paste it. All right. Here we go. This way we can see where we're flowing. Right, guys? Trying to help you out because it's kind of hard to see proofs if you can't continue to see the figure. Okay, so now we know that KR is congruent to PR, okay? Do we have any other givens? Yes. angle KRO is congruent to PRM. Okay? Angle KRO, which is, I'm doing it in a different color now. I'm going to do it in green. KRO is this guy. And that's congruent to PRM, which is this guy. So what can you tell from there? Yes, sir. Thank you. KRM is congruent to PRO because of subtraction. Very good job. You subtracted MRO from KRO, and you subtracted MRO from PRM. And now I can prove that triangle KRM is congruent to triangle PRO because of the angle side angle. All right, guys, so like I said, that's angle side angle. Please mark your figures. That is the best way to do this. And I thank you very much. Hope you learned a lot and have a wonderful, wonderful day.